All right, ladies and gentlemen, this is joint equilibrium. I'm going to go ahead and solve the first and second problem for you. Show you how to do it and let you go ahead and do it yourself. So here it is, and I've preloaded everything. Excuse me, sorry about that. So let's get it done. Uh, Joint equilibrium again just means the sum of the forces in the x have to be zero, and the sum of the forces in the y have to be zero. And in this case, it's at joint D, right? So x's means my lefts have to be equal to my rights. I've got 39 going to the right. So I need somehow to have 39 going. I'm sorry. I have 39 going to the left from member BD, right? So I somehow need 39 going to the right. And over here, my ups have to be equal to my downs. And I've got 25 pounds going up from member CD. So somehow I've got to have the same going down. Over here, my image shows me I've got member DM. So it, of course, is going to have to be the counter to those two. So it's going to have to go right, which it's going to the right, and it's going down to counter CD going up. So we know that M in the x direction will be 39, and dm in the y direction has to be 25. So basically, if this is dm, it has the components, and they are 39 in the x and 25 in the y. So how do we know how much dm is? I think that's what they ask us, to determine the force in member dm. So to figure out dm, we're going to do Pythagorean theorem, which you'll all recall: a, b, and c. A squared plus b squared equals c squared, or c is equal to the square root of a squared plus b squared. So we're just going to plug those in right here and say that dm is the square root of 25 squared plus 39 squared. I'll put that in my calculator. Second square root, 25 squared plus 39 squared, and it gives me the answer, 46.325 pounds force. That's how much is in member DM. Now the second problem here, sorry, let's give you one more quick look at that. Apologize. And the second problem here, I've also preloaded. I hope you don't mind. And it calls for us to solve for how much is in member TS in this case. Same exact stuff. I've got to look at my sum of the forces in the x direction being zero, and that's at point T this time, and sum of my forces in the y direction at point T equals zero. So x direction, I got 109 going to the right. I've got CT going to the left, 41. And they're supposed to be equal. So I know that TS in the x direction is going to have to go to the left, which means it's also going to bring it down. And that works out because TS in the y going down will be equal to BT going up, which is 80 pounds of force. So how much is TS in the x? Well, 109 is equal to 41 plus TS in the x. So TS in the x is 109 minus 41, which is 68 is TS in the x. And again, TS in the y we know is 80 pounds of force. So just like we did on the last problem, all we're going to do is quickly Pythagorean theorem, the square root of 68 squared plus 80 squared, and that gives me my answer. Second square root, 68 squared plus 80 squared, and I know that TS in the is 104.995 pounds of force. All right, thanks for watching. As always, smash that like button, ring that bell, and holler at me in the comments below. Stay safe, ladies and gentlemen. Make good